So in the previous video, we designed the tank till step 4, and now we have started with step 5, the reinforcement in vertical direction. So we have seen the dead load transferred to walls by the roof slab as 3188 Newton per meter, and what is remaining is the weight of the wall up to its mid height, the weight of this tank wall. So we know the height of the tank is 2.25, and by 2 up to mid height it will be by 2 into 0.15 is the thickness of the wall, and into 25,000 will give you 4219. So the vertical thrust in wall at its mid height, let it be P, that is equal to 3188 plus 4219, that we are getting as 7407 Newton per meter. The maximum bending moment in the vertical direction occurs at midpoint of CD, and its value is given as MV, or we found out it as plus 4912 Newton meter, and which is taken as sagging. Okay, so this was the value that we have found out in step 2. Our MV value is 4912 in CD, that is plus value, and this is maximum at the midpoint. Okay, all this we have found out in step 2. So what we are getting is MV is plus sign, that means it's sagging. So in the vertical direction, the reinforcement will be provided opposite to the water face, because the sagging occurs on the outer side of this tank, right? The sagging will be something like this, the outer side of the tank, and hogging inside towards the inside portion of the tank. Okay, so as the moment is sagging, we have to give the reinforcement away from the water face. So this is our AST. Then we have to draw our axial load and moment diagram. The P will be towards this because it's a thrust, and M for bending like this, our M should be in the anti-clockwise direction, and once our M is in the anti-clockwise direction, then our equivalent load at an eccentricity will be towards the left of the section. That will bring a anti-clockwise moment. Okay, it is not to the right, but it's to the left because of the direction of the moment is taken as anti-clockwise here. So the eccentricity of the thrust we are finding out by the same equation, M by P, and what we are getting is 663, and we marked here 663 mm. So again, the stress diagram is plotted here, C and T we got here. In this case, the vertical reinforcement are provided at the outer face. Okay, it is provided at the outer face, and inside that the horizontal reinforcement is given. We have taken the effective cover of the horizontal reinforcement as 30 mm. So the effective cover of this vertical reinforcement will be still less than the 30 mm. So here we are assuming it as 20 mm, and thus the effective depth will be 150 minus 20, where 150 is our thickness, and what we are getting is 130. And in this case, for this case, we have to find out the depth of the neutral axis, which is K into D, and lever arm which is J into D. What we are getting is 57.5, and lever arm will be 111. We have to mark this in our diagram, 57.5 and 111. The total compressive force will be acting at a distance 57.5 by 3, because it is acting at the centroid of the compression region, right? So equating the moments about the compression region, what we are getting is 7407, that is our direct thrust, and it is acting at a distance of 663 minus 75 plus 57.5 by 3, and that will be equal to our MR, moment of resistance value, and hence we are finding out the AST as 353 mm squared, which is again less than our AST minimum, which we found out it as 600 mm squared. Hence we are giving the same amount of reinforcement, that is 10 mm dia bars at 130 mm center to center at the outer face in the vertical direction. Okay, so we are providing the same reinforcement in the vertical direction also, that is 10 mm at 130 mm center to center, both at the shorter side and at the longer portion. Provide the same reinforcement in the shorter wall also, as our MB value at EF is less than CD, because if you are checking our moment values, we can find out that the vertical moment at EF is again less than that of CD. So if at CD we are getting the minimum reinforcement, then we have to provide the same minimum reinforcement in EF also. That is why we are providing 10 at a 130 mm center to center. So the top and bottom slabs are designed as usual. While designing the bottom slab, direct tension induced in it should be taken into account. This will be equal to the shear force at the bottom edge of the wall. We can use table 4 for moment calculation. Okay, so this is our tank, the horizontal section of the tank at mid height. We are giving the torsion reinforcement, the hogging reinforcement inside at the water face, and away from the water face we are providing the horizontal reinforcement for sagging, and also the vertical reinforcement, which is also taken as sagging. Okay, that is why we are providing at the outer face. Okay, so this much was what we were planning to discuss in this video. Thank you.